This video will be the first look at solving linear equations. When solving linear equations, sometimes it's helpful to think about things as pictured here in this scale. We want to keep the scale balanced. Currently, what is on the left, x plus 6, is the same value as what's on the right, 10, because the scale is balanced. When we translate that to algebra, we would say one side of the scale, x plus 6, is the same or equal to the other side, which is 10. Now, our job is to get x by itself, but we've got to keep things balanced. So in order to get x by itself, we're going to first have to get rid of this 6. That is what is on the same side as the x. When I go to get rid of that 6, I want to try and cancel it out. It's currently a positive 6. So in order to get rid of it, we would need to subtract 6. Because 6 minus 6 is 0, and that means it's gone. But if we're going to subtract 6 from one side of a balanced scale, and we want to keep the scale balanced, we're also going to have to subtract 6 from the other side to keep it even. What I mean by that is this side still will have the same value as this side, or the same weight if you're thinking about a scale. If you had two things that weighed the same, and you subtract 6 from one side and subtract 6 from the other, you still have things that weigh the same, they just weigh differently. On the left, when we cancel out those 6's, all that's going to be left over here is x. On the right, we have 10 minus the 6, or 4. So now we know that x has a value of 4 for this equation. Let's take a look at an example. Again, we're solving for x, so we want to get x by itself. Currently, here is my x, and on this side of the equal sign, or this side of the scale, is a 3. And we can't have that 3 there. We need to move it to the other side. Well, think about what's happening to this x and this 3. They're currently being multiplied. So to move that 3, we would do the opposite of multiplication, which is division. So we're going to divide both sides by 3. But when I go to do that, this is a little problematic because dividing fractions is not the easiest thing like that. Instead of dividing by 3, think about how you would divide fractions. When you divide by fractions, we usually keep change flip, where we keep the first, change it to multiply, and do the reciprocal or the flip of the other. So instead of dividing by 3, what I need to do is multiply by its reciprocal. So we're going to multiply both sides by 1/3. That is effectively the same thing as dividing by 3. Now, if you do 1/3 times 3, you're going to get a 1. And 1x is the same thing as x. On the other side, we've got to multiply these fractions. So we're going to multiply across the top. That's going to give me a 4. And across the bottom, 5 times 3 is 15. So we know that x is equal to 4/15. Let's take a look at example 2. On one side of the scale, we have this 9 minus 2x, and on the other side, we have -3. Our job is to solve for x, so we want to get x by itself. That means we're going to have to move this -2, and we're also going to have to move this 9 to the other side. Because we're solving for x, we're kind of undoing things. We're going to use reverse order of operations. So the first thing you're always going to move to the other side is add and subtract. Now this 2 is being multiplied with the x, so we're going to hold on that. But this is an add or subtract, so we're going to move that 9. Remember, the goal here is to get the 9 to cancel out. So if you have a positive 9, to get it to go away, we would have to subtract 9, because 9 minus 9 is 0, and it'll be gone. But if I do that to one side, you've got to do it to the other. Now think about what's left. On the left side, we've got this 2x, but what kind of 2x? Don't lose that minus sign. He's still there. So this is like a negative 2x. On the other side, I have negative 3 minus 9, which is going to be negative 12. We're closer, but we're not quite there yet because we don't have x by itself. We still have a negative 2 sitting in front of it. That negative 2 is being multiplied with x. So to undo it or move it to the other side, we would do the opposite of multiply, which is divide. We're going to divide by negative 2. A common mistake students make sometimes is divide by a positive 2 instead of a negative 2. Because up here we do opposite signs, but that's because we're moving using adding and subtracting there. The opposite here is add and subtract. Those are opposites. Here, this is a multiply. The opposite of multiply is divide, so it doesn't change the number. The opposite bit is the divide. And then these guys are going to cancel out because negative 2 divided by negative 2 is 1. And so we just have 1x, which we typically write just as x. And on the other side, a negative over a negative is going to be a positive, and it's going to be a value of 6. Let's look at one more. Again, we want to get x by itself. My x is right here. So when you think about what's on each side, this side is negative 5. All the other stuff is on that side. To get x by itself, we're going to have to move both of these 3's so that x is alone. Remember, the first thing we do is move using add and subtract. Since there is a minus 3 over there, we move it to the other side of the equal sign by doing the opposite of minus 3, which would be plus 3. And what you do to one side, you have to do to the other. Negative 3 plus 3 is 0, so those are going to cancel out. Negative 5 plus 3 is negative 2, and I still have x over 3. Up next is this guy. We got to move him so that x is by itself. Currently, x is being divided by 3. So the way we undo that, or the opposite of divide, would be multiply. So we're going to multiply by 3. But what we do to one side, we have to do to the other side. On the right side, these 3's are going to cancel out, but maybe it's not quite intuitive on how that works. Remember, 3 is the same as 3 over 1. And when you're multiplying fractions, you can reduce first. So 3 on top cancels with 3 on bottom because those are reducing to a 1. And so this is now going to just be 1x or x on that side. The other side, we've got 3 times negative 2, which is negative 6. Now this is a completely okay answer, but if you feel better about it, you can rewrite it the other way. Doesn't matter. X is equal to negative 6, so negative 6 is equal to x. That means the same thing. Now, if you had extra time and wanted to check all of these, you can. What you're going to do is whatever the value for x is, you put it in the spot of x and see if it works. So we rewrite this equation, but instead of x, I'm going to put negative 6. And then we're going to work on simplifying this side. Now, when we're on one side and we're putting things together, we have to follow order of operations. So up first would be the divide. Negative 6 divided by 3 is negative 2. So I could change this bit to negative 2. And then negative 2 minus 3, this part right here, is negative 5. And we know that negative 5 equals negative 5, so it checks. You can check all of these, but you don't have to if you're running out of time or something like that. So I would suggest on a test, go through and do all these problems first, and then if you have time, go back and check. But our final answer is still this, x equals negative 6.